Alright, so we talked the other day about improper integrals when we have infinity in the domain. So let's take a look at what happens if we have infinity at like an asymptotic discontinuity, such as our example here, 1 over x to the 1/3, where x cannot be 0. Again, we call these asymptotic or infinite discontinuities because as we approach 0, we're going to get an asymptote. For example, if I were to sketch this graph right here, whoops, let me get my pen better. At 0, it's an asymptote, and we would get something like this. So the question is, it's kind of like, what would be the area of like this little piece right here? So to do that, we have to do an integral. But the problem is, it's improper again because we can't really let x be 0. Remember, we call it improper because we just can't substitute 0 in. So we have to make this part right here our limit. So when I rewrite my problem, I'm going to write this as the limit, and I'm going to call that as a goes to 0 of our integral. And I'm just going to write that as to the negative 1/3, and that's going to go from a to 1 this time. But be careful, because it's asymptotic, we have to deal with what part of the, where on the function are we doing. Because remember, limits cannot exist at asymptotes, so we have to talk about what's called single-sided limits again. So if you remember what a single-sided limit is, it says I'm only approaching from one side. And in this case right here, we're only coming in from the right side, so we're going to put a little plus sign on that 0 right there. Now, integrating this, not too bad to do. We're going to get x to the 2/3 times 3/2 from a to 1. And then we just apply our FTC. The limit as a goes to 0 from the right, we're going to get 3/2 minus 3/2 a to the 2/3. Remember, if I plug in the 1, I just get 3/2, right? That's my f of 1 minus f of a. Well, now notice, if a goes to infinity, if a goes to 0, this just goes away. So we're left with 3/2. So what happens is this area converges to 3/2. And there's our answer right there. Pretty simple to do. So let's try this next one. Again, same type of problem. Again, it is a rational function, and at 0, again, we do have an asymptote. So I'm trying to find from 0 to 1, so I'm kind of like looking at that area right here. But again, there's our problem. We have to use limits because x cannot be 0. So when we set this up, I'm going to write this as the limit as, again, a goes to 0 from a to 1, and I'm going to write this as x to the negative 3rd dx. X to the negative 3 to the dx. That's tough to say. But again, we have to deal with a single-sided limit, otherwise it would be a d and e, so it's going to be a plus because we're dealing with the right side. Because from 0 to 1, I'm on the right side of that function right there. So integrating, not that bad to do again. Plus, and we go from a to 1. This becomes negative 1 over 2x squared, so be very careful. Applying the FTC, f of 1 minus f of a. We get the limit as a goes to 0 from the right. And plugging in the 1, I get just negative 1/2. This becomes plus 1 over 2a. Now the difference is, as a goes to 0 from the right, this approaches positive infinity right there. Because remember, this is a rational function right here. Because remember, recall that the limit as x goes to 0 from either the left or the right of 1 over x is plus or minus infinity. So if I divide by 0, that becomes infinite. As I get closer to 0, this number becomes infinitely large. So it doesn't really matter if I'm taking this negative 1/2 and I add infinity. Well, that's just infinity. So in other words, this area doesn't converge, but it diverges instead. Very simple to do. Let's take a look at another one. Now we'll get slightly harder. In this case right here, again, it's a rational function, but this time our limit's at the 27. So if I were to rewrite this problem, I'm going to write this as the limit, and from the other day, I'm just going to call that b because it's from a to b. As b goes to 27, we'll talk about from where to where in a second, of dx over, and this goes from 0 to b, the cube root of 27 minus x to the 1/3. Now, from the left to right, a little bit tougher to do, but if I draw out the numbers from 0 to 27, I'm coming in on the left side. So we're going to make that a negative this time. Sometimes it's easy to draw like a little short little number line right there. rewriting this, I'm going to take the limit as b goes to 27 from the left, and I'm going to go 0 to b, and I'm going to write this as 27 minus x to the negative 1/3. Just take the antiderivative easier. This is a u substitution. U is 27 minus x. Du is just negative dx. I really want the negative. So I can integrate this real quickly. We get the limit as b goes to 27 from the left of the following. This just becomes negative u to the 2/3 times 3/2 from 0 to b. And I just plug it in. The limit as b goes to 27 from the left, negative 3/2 b to the 2/3. This becomes plus 3/2 times 0 to the 2/3. Now, whoops, made a mistake there. Made a big mistake. I did make a mistake. Because I'm using u and I didn't change my domain, I did make a mistake, so we got to fix this. We have to replace our domain. See, sometimes it's easy to make a mistake. We're not used to replacing our domain on u substitution, so we go from 0 to b. This becomes negative 3/2. You got to put that 27 minus x in. So, sorry about that. So we get the limit as b goes to 27 from the left. And now when I plug it in, I get negative 3/2, and this becomes 27 minus b to the 2/3 plus 3/2. If I plug in the 0, I just get 27 to the 2/3. And there we go. Now, from the left. Now as b approaches 27, this first term just becomes 0. But this right here just stays 3/2 times, and that just becomes 9, or we get 27 over 2. So be careful with this one. Because I changed my domain, I didn't change my domain here. I left it in terms of x. I have to replace my u. So be very careful. Very easy to make a mistake on those. So ignore that. Bad word now. So anyway, so let's go on to the next example, number 4. Over here. Very quickly. Now you should recognize. Oh no, focus. Alright, so again, like the last one, it's going to be a little bit tougher. We're going to have a u substitution. But even worse, my domain restriction is at 1. It's in the middle. Whoops. So, you let that focus for a second. My domain restriction is in the middle. So x can't be 1. So I have to write 2 integrals for this one. So the first one is going to go from 0 to 1. And that's going to be this x minus 1 to the negative 2/3 dx. And then from 1 to 3 of x minus 1 to the negative 2/3 dx. So there's not a negative, so I'm going to have 2 limits on this one, because I can't be 1 in either case. So for the first one, I'll say it's the limit as b goes to 1 of my integral, x minus 1 to the negative 2/3. And you might have got onto a pattern here, because if it's from 0 to 1, we're approaching from the left, so it's going to be negative. And the next one, the limit, and I'm going to still call that b because it's the same one. You can call it whatever you want. B goes from 1 from the right, and it's going to go from b to 3, and again, x minus 1 to the negative 2/3. This time it's going to be from the right side, because if I'm looking at 0 and 1, we're approaching 0 from the right, or 1 from the right, in this case. Sorry, it was 1 to 3. There we go, from the right side, dx. Now when I integrate these, I'm going to use u substitution again, so I'll try not to make the same mistake twice. You never know. So when I use u substitution here, I get the limit as b goes to 1 from the left. This just becomes x minus 1 to the 1/3 times 3 from 0 to b. And the same thing here. Because remember, this is just u right here. And I'm going to get u to the 1/3 times 3 from b to 3. Oops, now I got to replace my u. So I'm just going to write this as 3 times x minus 1 to the 1/3. Applying your FTC, we get the limit as b goes from 1 to from the left. And we're going to get 3 times b minus 1 to the 1/3 minus 3 times 0 minus 1 to the 1/3 plus the limit as b goes from 1 to the right. And plugging it in, we get 3 times 3 minus 1 to the 1/3 minus 3 times b minus 1 to the 1/3. And we're going to simplify a little bit. Just let b go to 1. I get 0. This just becomes plus 3 plus over here, that does nothing. That just leaves me 3. That becomes times 2 to the 1/3 minus, and that just becomes 0. So we're left with 3 plus 3 times the cube root of 2. Very ugly. All right, go to part 2, and we're going to take a look at the problem that involves everything we have learned so far.